Welcome students. In this class we will be learning how to solve this trinomial. Now this is the algorithm. I have already given a written demonstration of this question as to how we can solve this. You can also revisit that video lesson. In this case we are going to be utilizing JavaScript to code the entire question. So we are expected to solve 12x squared positive 17x positive 6. Now this is the algorithm. What we need to do is first we need to extract the 12 out of the coefficient of x squared and multiply it with 6. This is what we will be getting, x squared positive 17x positive 72. After which we will find all the factors of 72. I will write the code for that. And then what we are going to do is we are going to extract those factors of 72 that when added up will give us 17. So upon getting those factors, what we are going to do is we will place those factors and divide it by the coefficient of x squared. Now to do this in JavaScript we will have to extract the GCD. I will also write the code to extract the GCD, and that GCD will reduce 8 and 12 and 9 and 12 and finally rewrite the factors in this fashion that you see here, 3x positive 2 times 4x positive 3. So without any further ado, first I will be asking the user to enter the constant term and then the coefficient of x and the coefficient of x squared, and I will be giving a running demonstration and explanation of this entire procedure. So I've got this VS Code, and let me start off. So first what you're going to do is you will get the constant from the user. So I'm going to declare a variable as constant term is equal to, I'm going to convert it into parseInt and then prompt the user to enter the constant term. Okay, so having got the constant term, we will get the coefficient of x from the user. So please enter the coefficient of x term. So this is going to be, I'm going to utilize it like this, coefficient x underscore term. Okay, so these two are got. Next we will get the coefficient of x squared term from the user. So I'll just copy it and I will paste it. So this is going to be coefficient of x squared term. While representing it as a variable, we cannot use that cap sign, so we need to just express it in this fashion. So all of these three things are got. Now what I wish to do is I would like to know all of the divisors of the constant term. So we will create an array to store all of the divisors of the constant term. So this is going to be let divisors be equal to new array. So an array is created, and also we want to know the number of divisors. So we will have to create another variable to keep count of the divisors of the constant term. Now this is just additional, right? So we create a variable as count to be equal to 0. But it makes sense mathematically, right? If you are given a constant term or a term as such, we would want to know the number of divisors. Now after which what we're going to do is we will have to get two of the divisors such that the sum is equal to the coefficient of x. So we are going to come to that term little bit later, but first we want to get the divisors. So for getting the divisors, what we have to do is we will create a for loop and we'll check for all divisors of the constant term. So for that we will have, as I mentioned to you, we'll create a for loop. Let I be equal to, we have to start from 1 and then I is less than equal to the constant term that we have created and I is incremented. Now this is the conditional check. If the constant term use modular division I, if it is equal to 0, that means it's a divisor. Then what I'm going to do is I'm going to say count is equal to count plus 1. Now the point here is we will have to take care of the negative divisors. So in this case, instead of, that means if 2 is a divisor, then minus 2 will also be a divisor. So in this case I will just increment the value of count by 2. Every time I choose a divisor, the positive and the negative should also be included. So now I need to have a negative count also for the divisors. So I'm going to say negative divisors. I will declare this variable over here. Let negative divisors, and then I come over here. I need to capture the negative divisors. So to get the negative divisors, what I'm going to do is I'm going to multiply I by negative 1. And now we will push the value that has been captured. So we will have to get the array. Divisors is the array, and we will push the negative divisors first, and then we will push the value of I next, and we will get the information printed. So I'm going to say document.write. I will place the parenthesis. Probably I will say divisors. Divisors equal to the number of divisors would be accumulated in the array. So that goes there. Probably you can have a spacing. Okay, so now I'm going to get the count also. So I'll state here with the break tag total divisors equal to, we don't need all of this, you will just say count. Okay, so that is about the code. We will execute the code. So it says enter the constant term, that is 72. That's the question we are targeting, and the quotient of x is 17. The quotient of x squared, we are not going to be using it as of now, but still we will enter it. Clearly you can see the number of divisors here. You see these are the numbers that divide the constant term. So total is 24. So we will just move on. So the code is perfect, and the next thing what we need to do is we will have to find those two values, those two quantities that will sum up the quotient of x. So let me write that. We will have to get those two numbers. Why I'm talking about those two numbers? Because it's a quadratic system, right? So it only have two factors. Those two numbers which adds up to the coefficient of x. Okay, probably I will just paste it over here, which adds up to coefficient of x. So for that we will have to again run a for loop, right? So let me run it like this: for let I be equal to, I'm starting from 0 and I lesser than equal to, I need to get the total length of the array. So devices dot length, and then I is incremented. So this is the first for loop. When it comes inside, I need to run another for loop for j is equal to I plus 1, j lesser than equal to devices dot length, and j is incremented. Okay, so now we are to perform the check. So if the divisors of I added up with the divisor of j, if it is equal to the coefficient of x, then what do? We have to push them into a number. So I'm going to say number 1 is equal to divisor of I, and number 2 is equal to divisor of j. So we will have to declare these two numbers. So I'm going to go over here and I'm going to say let number 1 and let number 2. So these two numbers are declared. So now you go up over here and you got these numbers. So these numbers would give us the, how would I put it, those particular value, or I would say these numbers when added up would give us the coefficient of x term. So that is the simplest way. Now if you want, you can display the numbers. We will display the numbers out. So I will say document.write first number, or just you can just write what you want. First number is equal to number 1. Then probably you can put a break there. If not, everything would be clustered. And this is going to be number 2. The second number. So when I say number, I would, instead of saying second number, I will say the factors or the roots. First root, I think that's a better word. First root, second root. Okay, so we have got that. Let me go and refresh it. So constant term is 72, quotient of x is 17, quotient of x squared is 12. So clearly you see that these are the total, all of the devices, these are the total number of devices, the first root and the second root. It's beautiful. So now we have to go back and we will, as I've shown you, we will have to get the GCD. So for that I'm going to utilize the function concept. So I'm going to create a function that would calculate the GCD of number 1 with the coefficient of x squared. So let me write that down. We will now have to get the GCD of number 1 with the coefficient of x squared, and we will also have to get the GCD of number 2 with the coefficient of x squared. So these two things we need to get it. So for that we need to call a function, because we cannot be writing code for the GCD calculation redundantly. So we want to avoid that. So first what I'm going to say is I'm going to create a function. I'm going to say GCD calculator, and I'm going to pass two values, number 1 comma number 2. Okay, the function is created. I'm going to calculate the minimum. Say a variable is declared and we need to get the minimum of the first number with the quotient of x and second number with the quotient of x squared. It's not quotient of x squared. So I'm going to say number 1 comma number 2. Okay, and then let me create a variable called GCD and let it be equal to 1. After that, we will have to run a for loop for let I be equal to 1, I is less than equal to minimum value, and then I is incremented. Now we need to have a conditional check. Now if the number 1 modular division I, if it is equal to 0, along with that, if the coefficient of x squared term modular division I, if it is equal to, so in this case it's going to be number 2, right, because we're utilizing function. So if it is equal to 0, then what happens? The GCD value becomes equal to I. So that's how we calculate the GCD. So in this case we need to place that I there. Okay, so the GCD is extracted. Now we need to call the function. Now we would have to calculate GCD twice. So the function is ending over here, the for loop ends over here. So what we do is we have to return the value, return GCD. So that's the calculated value. So we will be returning that. Now we will have to call the function. Okay. So how are we going to call the function? So I'm going to be requiring GCD of two set of numbers. Number 1, which I have extracted here with the quotient of x squared, and number 2 with the quotient of x squared. So let me declare two variables. So this GCD is going to be performing the job of the reducer. That means, as I mentioned to you, we have 8 has to be divided by 12, right? So this GCD will reduce 8 and it will reduce 12. So I'm going to call it as reducer 1, reducer 2, and then I'm going to state here, let reducer, so I'm going to call here, so this is going to be GCD calculator. I'm going to pass the number 1 with the coefficient of x squared, and we'll also do the same thing over here, number 2 with the coefficient of x squared. So the GCD is extracted. Now after extracting the GCD, what we have to do is we will have to reduce the number 1 and the quotient of x squared, number 2 and the quotient of x squared. So for that we need to have 4 set of variables. So I'm going to name it as let numerator 1, denominator 1, numerator 2, denominator 2, right? So what is this going to be? nr1 is equal to the number 1 which we have got, that has to be divided by the reducer. So when it does, we will have a numerator. Similarly, our denominator 1 is equal to the coefficient of x squared divided by the reducer, right? Now similarly, nr2 is equal to number 2 divided by the reducer, and reducer 1, okay, and dr2 is equal to coefficient of x squared divided by reducer 2. Okay, that looks fine. So we get the numerator and the denominator, and we get the numerator for the second quantity and the denominator for second quantity. So now what we have to do is we will have to run the check we will have to perform the check. Okay, so how are we going to perform the check? The check would have to be performed here. So we cannot just simply divide the number 1 by the reducer 1. We cannot do that because I want them to be perfect divisors. So for that to happen, I'm going to put a condition here. If number 1 modular division of the reducer 1, if it is equal to 0, and see, this is why this condition is important, because if we don't place in this condition, we won't get the required result. This has to be in place. If this condition is true, if the reducer 1 is able to divide number 1 without a remainder, and the reducer 1 is also able to divide the coefficient of x squared without a remainder, then you perform this. Okay, you perform this, then you divide it and you extract the numerator. Divide the number 1 by reducer 1 and you extract the numerator. Similarly, you extract the denominator when the coefficient of x squared is divided by the reducer. So this is the all important condition. So this conditional check is required. Now similarly, we will have to have the next conditional check. So in this case, it's going to be if number 2 modular division reducer 2, if it is equal to 0, if it is equal to 0, and concurrently coefficient of x squared modular division reducer 2, if you get it equal to 0, then you divide number 2 and you extract the quantity. So we are actually looking for perfect division, so we don't want any fractional quantities. So that is all. Finally, what we need to do is we will have to display. We will display the output in factored form. Okay, so I'm going to say document.write. I will open a brick dr tag here, and then I will have to open a parenthesis. The first denominator dr1 with x. Okay, so that's the first quantity, and that has to be added with nr1, so numerator 1, so that's the second quantity, and I need to close parenthesis, then I open a parenthesis, and after opening a parenthesis I will have to place in the second denominator. Okay, so this is going to be dr2 with x plus, and then we will have to place nr2. Okay, that's a little bit challenging, but as you practice, you will be able to observe that you are becoming proficient in these format techniques. Okay, so that is all about. So I'm going to save it. So this is a 58 line code for solving a trinomial. Now the all important part here is to find out if we have any bugs. So I'm going over here. So the constant term is 72, coefficient of x is 17, coefficient of x squared is 12. Yes, beautiful. So we do not have any issues. We have got no bugs. You can clearly see that we have got 8 and 9 as stated to be as first root and second root. Now this will cause some ambiguity among people because of the fact that actually -8 and -9 are the roots of this original polynomial which we considered. So what I wish to do is, though I have selected 8 and 9 because of the fact that they add up to 17, but when we are presenting the output, we need to document the output a little bit more with clarity. What I'll do is, to avoid any ambiguity, I will display all of the information given, starting from the polynomial that we have assumed at the start. So we'll say document.write polynomial considered is equal to, I will place in x squared there because the coefficient of x squared is always 1. So this is the code or the application for targeting the polynomial that I had shown you in the start. So x squared is always going to be there. So I will just place x squared there. But the coefficient of x will change. So this is going to be the coefficient of x. So we will just place that there, followed by the x term. I need to have x term and then a positive sign and the constant term. So this will be the polynomial that we started off with. Probably we can have some spacing there. So there is no issue in this case. Now we will have to get the factors for this. So I will say document.write factors are, I will just say factors equal to, so that is going to be starting with x term, x positive, the number 1 that we have extracted, and x positive number 2. So there is no issue in this case also. The issue comes when we display the roots. So document.write root 1 is equal to, I will place a -1 multiplied with number 1. As I mentioned to you, this is to avoid the ambiguity. And this is going to be root 2. Now next is the polynomial that we have to target. So I'm going to state that original polynomial is equal to, so I will have to have the coefficient of x squared there along with the x squared term there, because the user might give any polynomial of the type that we have dealt with. So this code should be in a position to handle that. So this is followed by the coefficient of x term. So the coefficient of x term remains as it is. So there is no issue in that case. So that's the x term, and then we got the constant term. Okay, that's fine. And now we can actually get the factors. So document.write. What I will do is I will get in the factors which we have obtained. Now we can also display the roots. So document.write root 1 is equal to, we need to be a little bit careful in placing the roots. So that is going to be -1 multiplied with nr1, and it has to be divided by dr1. Okay, so that is going to be the first root. If we do not place it like that, we will actually end up in some situations where we need to go back and redo the entire process. So this would answer all of the requirements that we needed. So far we have got everything, and we need to cater one important thing. See, actually this constant term that we have placed here is not part of the original constant term, because the original constant term was different. So what I'm going to do is I will have to declare a variable, right? So I'm going to say let the original constant be this. I will enter the original constant. I will also ask for the original constant, right? And that is actually going to be the term that is placed there. Okay, so that one would complete the entire requirement. So no matter what the polynomial's coefficients are, we would still be able to get this out, right? So we save it, we go back, we refresh it. Okay, I'm running. Please enter the constant term 72. Please enter the coefficient 17, coefficient of x squared 12. The original constant, that was the start of the problem, that is 6. So let's see the number of factors, number of divisors. This is the factor, these are the roots, this is the original polynomial required, and this is root 1, that's absolutely correct, and this is root 2. Now this 17, I would say this 72 was obtained because we multiplied the original constant 6 with 12. So that is the reason that we got 72 there. Now what we need to do, we will have to reformat the code. I would say instead of saying reformat, we will have to reframe the code, because we are actually receiving this 72 because of the algorithm that we started off with. Now to avoid that, what we need to do is we can actually slightly change the code. Okay, so that's exactly what I'm going to do. What I'm going to do here for the constant term, I am just going to take this off. I'm going to take this off, and I will copy this over here. This is fine. I don't need these two lines. So we will get the coefficient of x, that's fine. The coefficient of x squared, that's right. The original constant is got here. And over here, I will place the constant term, and we are actually taking the original constant and multiplying it with the coefficient of x squared term. You follow me? So no matter what you are giving, what the original constant or what the values that we are giving from the original polynomial, this code will be able to answer them all. Okay, so that is the last part that I would like to draw your attention to. So now let me just go up over here and I'm going to ask, or I'm going to give in the values. The coefficient of x term is 17, fine. Coefficient of x squared term is 12 and the original constant is 6, right? So now you can clearly see that we are getting the same output, right? Polynomial considered, clearly all these things are generated from the input that we are given. So if we had to use some other polynomial of the following form, it will also work. Now I'm going to try another question just to show you that what code that we have got here is absolutely functional and it is very efficient. So in this case, enter the coefficient of x term. I'm going to enter 14. Enter the coefficient of x squared term. I'm going to enter 15. Enter the original constant, and clearly you can see the divisors, the total number of divisors, the polynomial considered. This is the starting point and its factors, its roots, and this is the original polynomial given. The coefficient of x being 14, coefficient of x squared being 15, and the constant term being 3. So this is the factor that we have extracted. The root, the first root is -1/3. The second root is -3/5. So that is the completion. Before I could move on, before we could end this lesson, please observe that we are actually dealing with polynomial of this nature. That means the sign before x squared should be positive, sign before x should be positive, the sign before 3 should be positive. And this particular application that we have designed is meant to cater polynomial of this form. Of course, we can add on certain restrictions and suitably alter the code, but as of now the code is 63 lines and I think this is the best place for us to stop. Thank you students. Please like, share and subscribe to our channel. Until we meet again.